There are two kinds of things that we're covering in this book. There are simulations, and then there are synthetic data. So, what are the what is the difference between those things? Do you use simulations to create synthetic data? Fill us in.
So in this case, we're using simulation to mean when we want to reinforcement learn something, teach it to perform some certain task, to reach some certain goal state, to animate when we haven't given a specific animation. Whereas synthesis is where we want to make some data set that we then take out of engine and then apply using traditional machine learning models. To say that you're trying to make a model in a domain where you don't have enough data, it turns out that even if you create synthetic data based on the data you have, and even though you might intuit that that means it can only be derivative of what you have, why would that make it any better? It turns out it does.
Mm.
And all of a sudden
Oh,
you have an infinite source of data.
wow. That is wild. I actually had a conversation many, many years ago, a phone call with this consulting company, and they were talking to me about simulating financial data. And I thought it was a really bad idea. I should go back and phone them. I think I was a bit snippy with them. I actually often regret that phone call because I was kind of like, I was quite dismissive. Um, and yeah, it sounds like from what you just said, I made a big mistake that in fact, synthetic data can be hugely valuable. They can even be, yeah, provide you with uh, maybe even better data than you could possibly collect in a particular situation.
Well, if you only have limited input data, you're always going to be limited in what you can do. And there's only so far that you can stretch it. Obviously, anything you simulate, anything you synthesize is going to be just reinforcing whatever's there. So if you have
Right.
something that's really messy or really ill-defined or something that's going to learn the wrong lesson, as we all know, machine learning is hard to wrangle sometimes. It learns the wrong thing. But if you're smart about how you use it and you're smart about the random variations that you introduce, that source of chaos, then
Right.
yeah, you can make something that's really robust.
That's cool. Yeah. And as you say, infinite amounts of it then. If you can simulate your synthetic data, then you can theoretically have as much as you need. So this is something, for example, that we see with self-driving cars. There's a lot of self-driving car footage out there of really boring situations. So going straight down a highway, self-driving cars collect lots and lots of data that show that, but
Yeah.
there isn't really anything that needs to be learned, particularly in that case. What we want to be learning is the irregular circumstances when a pedestrian jumps out in front of the road, or a cow jumps in front of the road, or you're in a city with all kinds of things going on. And so a lot of self-driving car companies simulate data of the kind of edge cases so that you have lots of examples of training data to train self-driving cars on. So
That's a
that's
great
kind of
idea.
one.